Hello students, welcome to this lecture on surface areas and volumes. So in this lecture, we will discuss exercise 12.2. So in our previous lecture, there we have discussed volumes of a combination of solids, and then we discuss exercise 12.2, question number 1, 2. Okay, so in this lecture, we will discuss question number 3. So in this question, we have gulab jamun which contains sugar syrup up to about 30 of its volume. So we have to find approximately how much syrup would be found in 45 gulab jamuns. Okay, it's shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So you can see this figure. So in this figure, basically we have 45 gulab jamuns. Okay, and a gulab jamun contains sugar syrup up to about 30 of its volume. Okay, and here we have given length length is 5 centimeter and diameter is 2.8 centimeter. Okay, so let us solve this problem. So from this figure so you can observe that radius of the cylindrical part, this is actually equal to radius of hemispherical part. Okay, and this is equal to 2.8 by 2. Since we have given the diameter of the gulab jamun is 2.8 centimeter. Okay, so now the radius of the cylindrical part, this is actually equal to radius of the hemispherical part, and this is equal to 2.8 by 2, and this is equal to 1.4 centimeter. Okay, so now length of each hemispherical part, this is equal to radius of hemispherical part, and this is equal to 1.4 centimeter. And length of cylindrical part, this is equal to 5 minus 2 times length of the hemispherical part. And we have found the length of hemispherical part, that is equal to 1.4. Okay, so now length of cylindrical part, this is equal to 5 minus 2 times length of hemispherical part, and this is equal to 5 minus 2 times 1.4, and this is equal to 2.2 centimeter. Okay, so length of cylindrical part is 2.22 centimeter and length of hemispherical part is 1.4 centimeter. And now volume of one gulab jamun is equal to volume of the cylindrical part plus 2 times volume of the hemispherical part. Okay, so we know that volume of cylindrical part is pi r square h, where r is the radius of the cylindrical part and h is the height of the cylindrical part. Okay, and we know that volume of hemispherical part, that is equal to 2 times volume of the hemispherical part, this is equal to 2 by 3 times pi r cube, where r is the radius of the hemispherical part. Okay, so now volume of one gulab jamun, this is equal to volume of cylindrical part plus 2 times volume of the hemispherical part, and this is equal to pi r square plus 2 times 2 by 3 times pi r cube. Okay, and this is equal to pi r square h plus 4 by 3 pi r cube. And here we have given the value of r is 1.4 centimeter and the height of the cylindrical part h is 2.2 centimeter, and we have radius of the hemispherical part is 1.4 centimeter. Okay, so now if we put these values in this formula, then we will get the volume of one gulab jamun, this is equal to 5 times 1.4 square into 2.2 plus 4 by 3 times pi into 1.4 cube. Okay, and now if we put the value of pi, this is equal to 22 by 7. Okay, in this formula, then you will get this is equal to 22 by 7 into 1.4 into 1.4 into 2.2 plus 4 by 3 into 22 by 7 into 1.4 into 1.4 into 1 by 1.4. Okay, and if we calculate it, then you will get this is equal to 13.552 plus 11 times 498. Okay, and if we add them, then you will get this is equal to 25.05 centimeter cube. Okay, so volume of one gulab jamun, this is equal to 25 25.05 centimeter cube. Okay, and now volume of 45 gulab jamun, this is equal to 45 times volume of 1 gulab jamun. Okay, so here we have volume of 1 gulab jamun, this is equal to 25.05 centimeter cube. Okay, so now volume of 45 gulab jamun, this is equal to 45 times 25.05, and if we now multiply them, then you will get this is equal to 1127.25 centimeter cube. Okay, so volume of 45 gulab jamuns, this is equal to 1127.25 centimeter cube. Now volume of sugar syrup, this is equal to 30 of volume. Okay, so this is equal to 30 by 100 into 1127.25, and if we calculate it, then you will get this is equal to 338.17 centimeter cube. Okay, and this is approximately equal to 338 centimeter cube. Okay, so the volume of sugar syrup, this is equal to 338 centimeter cube. Okay, now let us move to question number 4. So in this question here we have a pen stand made of wood is in the shape of a cuboid with 4 conical depressions, okay, to hold pens. The dimension of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depressions is 0.5 centimeter and depth is 1.4 centimeter. And now we need to find the volume of the wood in the entire stand. Okay, so you can see this figure. So here in this figure, basically we have given a pen stand which made of wood is in the shape of a cuboid with 4 conical depressions. Okay, so these are conical depressions, and this part is actually look like cuboid. Okay, we have given the dimensions of the cuboid are 15 centimeter by 10 centimeter. Okay, and by 3.5 centimeter, and radius of each of the depressions is 0.5 centimeter and depth is 1.4 centimeter. So now let us find the volume of wood in the entire stand. So let us solve it. So here you can see this figure, this figure. Okay, and from this figure here we have given basically in this problem depth of each conical depression, that is equal to 1.4 centimeter, and we have given radius of each conical depression is 0.5 centimeter. And now volume of wood, this is equal to actually volume of cuboid minus 4 times volume of cones. Okay, so we know the formula for volume of cuboid and we know the formula for volume of cones. So if we now use this formula and if we put the value of H and R, then we'll get the volume of wood. So here the volume of cuboid, this is equal to length into breadth into height, that is LBH. Okay, and minus 4 times volume of the cones. So volume of cone is 1/3 pi r square h. So this is equal to LBH minus 4 times 1/3 pi r square h. And here we have given the length L is 15, B is 10, and H is 3.5. Okay, and we have given the radius R is equal to 1 by 2, that is 0.5. Okay, and H, height of the cone, is equal to 1.4. So if we put these values in this formula, then we'll get this is equal to 15 times 10 into 3.5 minus 4 into 1 by 3 into 22 by 7 into 1 by 2 square into 1.4. Okay, and now if we calculate it, then you will get this is equal to 525 minus 1.47, and this is equal to 523.53 centimeter cube. Okay, so therefore the volume of wood, this is equal to 523.53 centimeter cube. And now let us move to question number 5. So in this question here we have a vessel is in the form of the inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. Okay, so it is filled with filled with water up to the brim when lid sorts, each of which is sphere of radius 0.5 centimeter, are dropped into the vessel. Okay, 1/4 of the water flows out, and now we need to find the number of lids sorts drop in the vessel. So basically we have given a vessel is in of the form of an inverted cone, and its height is given to us 8 centimeter, and radius of the top, which is open, is 5 centimeter. Okay, and we also have given radius of a sphere is 0.5 centimeter. Okay, so now let us solve this problem. So first of all, you need to draw the following situations by a figure. Okay, so you can draw this figure. So this is our figure, and here this height is 8 centimeter, and the radius of this cone is 5 centimeter. Okay, so height h of conical vessel is 8 centimeter, radius r1 of conical vessel is 5 centimeter, and radius of r2, that is lids of sorts, this is equal to 0.5 centimeter. And then we let the number of lid sorts were dropped in the vessel be n. So n be the number of lid sorts were dropped in the vessel. And now volume of water spill is equal to volume of drop lid sorts. This is 1/4 times volume of cone into n into 4/3 r2 cube. Okay, so here where this implies 1/4 times 1/3 times r1 square into h, this is equal to n times 4/3 times 5 r2 cube. Okay, so now if we simplify this equation, then we'll get r1 square times h is equal to n times 16 r2 cube. Okay, and it implies 5 square times 8, this is equal to n times 16 times 0.5 cube. So here basically we put all these values. R1 is 5, h is 8, and r2 is equal to 0.5. Okay, and we get 5 square times 8 is equal to n times 16 times 0.5 cube. Okay, and now if we simplify this equation, then we get the value of n. So n is basically equal to 25 times 8 divided by 16 times 1/2 whole cube, and this is equal to 100. Okay, so we get the value of n is equal to 100, hence the number of lid sorts drop in the vessel is 100. Okay, and now let us move to question number 6. So in question number 6, here we have a solid iron pole consists of a cylinder of height 220 centimeter and base diameter is 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. So we need to find the mass of the pole, given that 1 centimeter cube of iron has approximately 8 gram mass. Okay, so for finding the mass of the pole, basically we need to find the volume of the pole. Okay, and we are given that 1 centimeter cube of iron has approximately 8 gram mass, and here we have to use the value of pi is equal to 3.14. so let us solve this problem. So first of all, draw the figure. So here this is the figure. Okay, so here the diameter is 24 centimeter, and then radius is 24/2, that is 12 centimeter, and total height is 200 to 220 centimeter. Okay, and from the figure it can be observed that height which h1 of larger cylinder is 220 centimeter. Okay, and radius r1 of larger cylinder is 24/2, that is equal to 12 centimeter, and height h2 of smaller cylinder, this is equal to 60 centimeter, and radius r2 of smaller cylinder, this is equal to 8 centimeter. Okay, now total volume of pole, this is actually equal to volume of larger cylinder plus volume of smaller cylinder. Okay, so first of all we need to find the volume of larger cylinder, and then we need to find the volume of smaller cylinder. Okay, then if we add them, then we'll get total volume of pole. So here the large volume of the larger cylinder is basically is equal to pi r1 square times h1. Okay, and the volume of the smaller cylinder is basically equal to pi r2 square times h2. Okay, so here r1 is basically radius of the larger cylinder, h1 is the height of the larger cylinder, and r2 is the radius of the smaller cylinder, and h2 is the height of the smaller cylinder. Okay, and then volume of the larger cylinder is pi r1 square h1, and the volume of the smaller cylinder is pi r2 square times h2. Okay, and this is equal to 5 times 12 square times 220 plus pi times 8 square times 60. Since r1 is equal to 12 and h1 is equal to 220 and r2 is equal to 8 and h2 is equal to 60 centimeter. Okay, so and if we now calculate this, then we will get here we can first of all common out pi. Okay, and then we'll get pi times 144 times 220 plus 64 times 60, and this is equal to 35520 times 3.14. So here we put the value of pi is 3.14 and we get 35520 times 3.14, and if we multiply them, then you will get this is equal to 1111532.8 centimeter cube. Okay, so here we get the volume of the pole. This is equal to 111,532.8 centimeter cube, and we have given mass of 1 centimeter cube iron is equal to 8 gram. Okay, so now mass of 111,532.8 centimeter cube volume iron is equal to 111,532.8 times 8, that is equal to 892262.4 gram. Okay, and this is approximately equal to this is in gram 892262.4. Okay, and if we convert it into kilogram, then you will get this is equal to 892.262 kilogram. And now let us move to question number 7. So in this question, here we have a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Okay, so basically we have a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter. Okay, and they are placed upright in a right circular cylinder full of water such that it touches the bottom. Okay, and now we need to find the volume of water left in the cylinder. So if the radius of the cylinder is 60 centimeter and its height is 180, then we need to find the volume of the water left in the cylinder. So student, let us find the volume of water left in the cylinder when the radius of the cylinder is 60 centimeter and height is 180 centimeter. Okay, let us solve this problem. So first of all, we can draw the figure. So if we draw the figure, then you will get like this figure. Okay, so this is the actual figure of the following situation. So now here it can be observed that here radius r of hemispherical part, this is equal to radius r of conical part, and we have given radius of hemispherical conical part is 60 centimeter. Okay, so the radius of hemispherical part, this is equal to also 60 centimeter, and height h2 of conical part of the solid is given to us, that is 120 centimeter. So height of the conical part of the solid is 120 centimeter, and now height h1 of cylinder, this is equal to 180 centimeter, and now radius of cylinder, this is equal to 6 centimeter, and now we need to find the volume of water left. So volume of water left, this is equal to actually volume of cylinder minus volume of solid. Okay, so if we subtract volume of solid from the volume of cylinder, then we will get the volume of water left. So here this is equal to volume of cylinder minus volume of cone plus volume of hemisphere. Okay, so volume of solid basically is equal to volume of cone plus volume of hemisphere. So we know the formula for volume of cylinder, that is equal to pi r square h1, where r is the radius of the cylinder and h1 is the height of the cylinder. Okay, so volume of cylinder is basically equal to pi r1 square h r pi r square h1, and we know the formula for volume of cone, that is 1/3 pi r square h2, where r is the radius of the cone and h2 is the height of the cone. Okay, and we know the formula for volume of hemisphere, that is equal to 2/3 pi r cube, where r is the radius of the hemisphere. Okay, so now if we take this formula in here, then we will get pi r square h1 minus 1/3 pi r square h2 plus 2/3 pi r cube. Okay, and now if we put all these values, r is 60, h1 is 180, h2 is 120. Okay, and r is 60. So if we put all these values in this formula, then we will get this is equal to pi times 60 square times 180 minus 1/3 pi 60 square into 120 plus 2/3 pi 60 cube. Okay, and here from this from there you will get you can take common out pi into 60 square. Okay, and then you will get pi times 16 square times 180 minus 40 plus 40, and this is actually equal to pi times 3600 into 100, and this is equal to 36000 pi centimeter cube. Okay, and if we now put the value of pi, okay, if we put the value of pi is 3.14, then you will get this is equal to 1131428.57 centimeter cube. Okay, and now if we convert centimeter cube into meter cube, then 1131428.57 centimeter cube, this is equal to 1.131 meter cube. Okay, so the volume of water left is equal to 1.131 meter cube. Okay, now let us move to question number 8. So in this question here we have a spherical glass vessel, has a cylindrical neck 8 centimeter long and 2 centimeter in diameter. Okay, the diameter of the spherical part is 8.5 centimeter, and by measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. And here check whether C is correct. Taking the above as the inside measurements, and take pi is 3.14. So in this problem, basically we have given a spherical glass vessel, has a cylindrical neck 8 centimeter long and 2 centimeter in diameter. Okay, and we have given the diameter of the spherical part is 8.5 centimeter. Okay, and by measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Okay, so now we need to check whether the C is correct or not. Okay, so let us check. So first of all, draw the figure. So this is the figure where this is spherical part, this is a spherical part, and this is cylindrical part. So height of cylindrical part is given to us 8 centimeter, and radius R2 of cylindrical part is 2/2, that is equal to 1 centimeter. Okay, and radius R1 of spherical part, this is equal to 8.5/2, this is equal to 4.25 centimeter. And now we need to find the volume of vessel, that is actually equal to volume of sphere plus volume of cylinder. Okay, so if we add volume of sphere and volume of cylinder, then we will get volume of vessel. So we know that volume of sphere, this is equal to 4 by 3 pi r1 cube, and we know volume of cylinder is pi r2 square h. Okay, so now if we put the value of r1, r2 and h, then we'll get volume of vessel. This is equal to 4 by 3 pi times 8.5 by 2 cube plus pi times 1 square times 8. Okay, and if we now simplify it, then you will get this is equal to 321.392 plus 25.12. Okay, and if we add them, then you will get this is equal to 346.512. Okay, and this is approximately equal to 346.51 centimeter cube. Okay, but see, but a child finds its volume to be 345 centimeter cube, but here we get the volume of the vessel is 346.51 centimeter cube. Okay, hence C is wrong. So now let us summarize whatever we covered in this chapter. So in this chapter we have studied the following points. So first point is to determine the surface area of an object formed by combining any two of the basic solids, namely cuboid, cone, cylinder, sphere and hemisphere. Okay, so we determine the surface area of object that formed by combining any two of the basic solids. Okay, and if we take a solids that actually formed by combining cone and cylinder. Okay, that case we get total surface area of the solids. This is equal to curved surface area of cone plus curved surface area of cylinder. Okay, and then we have studied in our previous lecture. Okay, so second point, to find the volume of objects formed by combining any two of the cuboid, cone or cylinder, sphere and hemisphere. Okay, so suppose if we take a cuboid and if we take cone, okay, then you need to find total volume of the solids, that is equal to volume of cuboid plus volume of cone. Okay, so by using this concept we find the volume of objects formed by the combining any two of the cuboid, any two of the solid, okay, like a cuboid, cone, cylinder, sphere and hemisphere. So I stop here this lecture. Thank you very much to all of you.